All right, just continuing on with our 10.4 notes, ellipses. Okay, so now in this lesson, we're going to learn how to write the equations of those ellipses. Okay, so typically I'm going to give you two things. I'm going to give you vertices, covertices, vertices, foci, covertices, foci. Two of those three things. So in this one, we got vertices and covertices. Okay, so let's go ahead. Let's just plot those points. We got negative 3, 0, 3, 0 for our vertices. And then it's 2 root 2, which is about 2.8. Okay, so from there, given those points, I can figure out my center. Okay, on this one, it is centered at 0, 0. Okay, so we'll just go up here. Center is 0, 0. Now, when we're writing the equation of ellipse, remember it's x minus h squared over a squared plus y minus k squared over b squared is equal to 1, or a squared and b squared could be flip-flopped. Okay, so just remember a squared is always the larger value. Now, the big thing to know from there is just knowing, okay, we went left and right, 3 from that center, so that's going to be the one that goes under x. Okay, so in this case, remember center is your HK. So right there, I'm given that. So let's go ahead, let's write that in there, replace h and k with that. So x minus 0 squared, y minus 0 squared. And the one thing, it should always equal 1 when it comes to writing the equations of ellipses. Now, with these, when I'm given the vertices and covertices, okay, I can figure out a and b. Okay, so in this case, a, which is our left and right because of the vertices, okay, that's 3, meaning a squared would be 9. Okay, that b value, we went up and down 2 root 2. Okay, so b squared, that's saying 2 root 2 times 2 root 2, which would give us 4 square root of 4. Square root of 4 is 2, so 4 times 2, or 8. Okay, so since I have a squared and b squared, that is what I need for my equation. Got a squared, b squared. Okay, now that a squared, that's when we went left and right, so that's under x. Oh, helped to write the right number. So 9, and the b squared will be 8. Now, I don't want us to leave it that way. X minus 0 squared, that's just going to be x squared. Y minus 0 squared, that's just going to be y squared. And it's set equal to 1. So when it comes to writing the equations, what it comes down to is finding your center, finding your a squared, finding your b squared. Okay, so on this next one, now we're given the foci and the vertices. Okay, so let's go ahead, let's plot those. We got 3, 6, 3, negative 2. Okay, and even just from those points right there, we can figure out our center. Okay, so the middle of 6 and negative 2, that's a distance of 8. So divide that by 2, we get 4. That's going to put us at 3, 2. Now, our foci, we're at 3, 5, and 3, negative 1. So vertices, vertices, foci, foci, and then there's our center. So again, we got our center at, what do we say, 3, 2. Okay. A and B, we can figure out A and B from that. Okay, A is that distance from the center to the vertices again, which we said was 4, meaning A squared would be 16. B, okay, that's the tricky part, because remember, B is that distance from the center to the co-vertices. Okay, so what we're going to have to do is we're going to have to use C squared is equal to A squared plus B squared. Okay, because I'm given that C, because remember, the C value is the distance from the center to your foci. So in this case, 1, 2, we got a distance of 3. So let's just write A, B, and C here. We said C was 3, and we had an A of 4. Okay, so from that, plug it into the formula of C squared equals A squared plus B squared. We're going to get 3 squared is equal to 4 squared plus B squared, or 9 is equal to 16 plus b squared. Okay, bringing that over, you're going to get negative 7 is equal to b squared. Okay, now, made a mistake somewhere in there. Oh, because it's not plus b squared, it's minus. Okay, so it's important to know the signs. Minus, minus, minus. So negative b squared equals negative 7, meaning b squared is equal to 7. Okay, now I don't need to figure out b. B would be square root of 7, but in our equation we need a squared and b squared. So again, x minus h squared over, in this case, would be b squared, because up and down is that major axis, so it would be b squared in this case. Y minus k squared over a squared is equal to 1. Now, just don't worry about flip-flopping a and b. Just know we went up and down that 4, so that means that has to go under the y. So our center, x minus h, so x minus 3 squared, y minus 2 squared, set it equal to 1. Okay, up and down 4, so 4 squared, we're going to get 16. And we said we got that other b squared value of 7. Just plugging that into that empty spot. So there's our equation for the ellipse that has those vertices and those foci. Okay, so one more. So now I'm going to give you covertices and vertices. So here we got 6, 4, 0, 4, 3, negative 1, and 3, 9. Okay, those are my vertices. These are my covertices. Okay, so center would be right in the middle there, which is at 3, 4. Okay, so x minus h squared. We're not even going to write that here because I'm going to ignore that. So let's just go ahead. Let's put our h and k in right away. We're going to have x minus 3 squared over something plus y minus 4 squared over something is equal to 1. Okay, so then there, I'm just going to go to our points that we plotted up and down. Okay, that's under our y. We went up 1, 2, 3, 4, 5. Okay, so up 5, 5 squared is going to give me 25. Okay, left and right 3, so 3 squared is going to give us 9. So there is our equation for the ellipse with those vertices and covertices. Okay, so the big thing again, find your center, find your a, find your b, and then a squared and b squared will be in the equation. Okay, if you're not given a or b, you're going to be given c. So then again, using that, c squared is equal to a squared minus b squared. Okay, and then plug it into c, and then either a or b depending on what you're given. And again, a is always going to be that distance from the center to the vertices. B will always be that distance from the center to the covertices. All right, so that is writing the equations of ellipses. Okay, for the homework on this one, ellipse equations, day 2. Okay, so go ahead, work on that homework. Otherwise, have a good day.